Hey everyone, this is Math Done Right, and today we're going to be doing part 2 of our system of equations video with infinitely many solutions. And let's just remember that what we're doing here is really solving multiple equations with multiple variables simultaneously. Before we get started with some examples, I'm going to kind of talk about what does it mean for a system of equations to have infinitely many solutions. So let's say I just draw my xy axis. And let's say I'm given two lines. So I'm going to use orange and blue. So let's say my first line looks like this. I'm going to call it L1. Now for a system to have infinitely many solutions, what that really means is that my two lines are on top of each other. Or we could say that they're the same line. I'm going to call that one L2. So if I have a system and I get that my two lines are the exact same line, well, that means I'm going to have infinitely many solutions. Alright, so let's look at our first example now. It's going to be x plus y equals 3 and 3x plus 3y equals 9. Now with this first method I'm going to show you, I'm going to want to look at these two equations and try to think, is there a certain number I can multiply one equation by to get the second equation? And if I look at this first one, if I multiply everything by 3, I can see that I get the second one. So let's go ahead and do that out. So if I have 3 times x plus y equals 3 times 3, I get 3x plus 3y equals 9. And I compare these two and I notice that I get the same equation. Now at this point I already know I have infinitely many solutions because I have one equation with two variables. That's always going to give me infinitely many solutions. And that's true in general actually. If I had 3 equations with only 2 variables, I would have infinitely many solutions. So if I have more variables than equations, that's going to give me a scenario which I have an infinite amount of solutions. So let's try to find out what some of the solutions look like. Well, to do that, I can make a line out of this guy. So let's write down the equation. And let's try to solve for y here. So I'm going to do that by subtracting 3x from both sides. I get 3y equals 9 minus 3x. If I divide everything by 3, I get y equals 3 minus x. Now I'm going to plot this line onto a graph. So I'm going to draw my coordinate system. So I have my x, y axes, and I know I have a y-intercept of 3 and a slope of -1. So my graph is going to look something like this. It's going to go through both of these points. Keep on going. And so when we say that we have infinitely many solutions, I can't just say like, yeah, x equals 1, y equals 1 is a solution. First of all, that doesn't make sense, right? 1 plus 1 doesn't give me 3. It has to fit this equation of the line that we have here. But I can pick any x value I want. Let's say I pick x equals 1. Well, if I plug this 1 in for here and solve for y, I get y equals 2. And now if I plot that on my graph, oh, the point 1, 2 is on my graph. So this is a solution, and I can get another solution. I can look at x equals 2. Now if I have x equals 2 and plug it into my equation, I get y equals 1, and that's another solution. So x equals 2 is here, y equals 1 is there, and I get this point right here. And so when we say we have infinitely many solutions, it means that this whole line, any ordered pair that fits this line, will satisfy these equations. Now let's look at this one. 1 over 5x minus 2y equals 1, and x minus 10y equals 5. Now this one might be a little trickier to think, okay, what number do I have to multiply this one or this equation to get this equation? But if we really think about it, if I multiply this guy by a 5 and this by a 5 and this by a 5, I get the second equation. But let's solve this in a different way. So let's, if we reference back to part 1 where I had the method of substitution, I'm going to solve it that way. So let's do substitution. Now, I want to look at these two equations and see if there's any variable that's easy to solve for in either equation. Well, if I look at this one, my second equation, it's really easy to solve for x if I add 10y to both sides. So that gives me that x equals 5 plus 10y. Now what I'm going to do is exactly what I did before in part 1. I'm going to take this x and shove it into my first equation right there. Now when I do that, I'm going to get 1 over 5 times 5 plus 10y minus 2y equals 1. Now I have a linear equation in the variable y and I can solve for it. So I distribute this 1/5 here and I get 1/5 times 5 gives me 1. 1/5 times 10y gives me 2y. Then I have minus 2y equals 1. Now my 2y and plus 2y minus 2y cancel each other out, and so I'm left with 1 equals 1. And that looks kind of weird, right? Well, this is always true. 1 is always equal to 1. And so when we get something that is of this form, like one number equal to the same number, that's when I have infinitely many solutions. Infinitely many solutions. So the first way was the first problem I did, I tried to see if I got the same equation by multiplying by a number. And this way I tried to solve it like I would regularly, but I found out that I had one number equal to the same number. And that case gives me infinitely many solutions. Alright, well that's all I have for solving a system of equations with infinitely many solutions. Make sure to like and subscribe and check out part 3, which is going to be solving a system that has no solutions. Thanks, bye.